Trystan Watson, lead of photovoltaics for Specific Innovation and Knowledge Centre at Swansea University. Here at Swansea, we develop functional coatings that capture, store and release energy as part of a programme of research that leads to buildings that capture, store and release energy. In particular, we work on printed photovoltaics. What this means is that instead of your conventional silicon solar cell that you might buy in a panel and apply to your roof, we develop coatings of photovoltaics and photovoltaic layers that can be printed onto glass or metal or plastic. And that comes with a range of different challenges. How do you turn the photoactive material into an ink? How do you apply it onto the surface? How do you dry it? How do you coat it? And how do you get it to work just as well as the existing products that are out there? So the reason that we do this is so that we can integrate these technologies directly into the fabric of the building. So instead of making a building and then drilling a hole in the roof and applying a solar panel, what we want to do is actually print the PV and photoactive material directly onto the roofing product. If that's glass for a window or metal for a roof, we can apply it directly. We also then want to look at how long it lasts, how well it behaves. We want to try and understand why it works so well or why it doesn't work. And so the sort of projects that we carry out range right the way from understanding the coating processes, right to understanding why they behave as they do, right to understanding how long they last. Because ultimately we want to create a sustainable industry of photovoltaics here in the UK. So we have a range of different equipment here at Swansea University, which can allow you to do all sorts of experiments in printing, in coating, in measuring, analysing, both during the coating processes and afterwards. You can look at the behaviour of the coating in terms of its performance, in terms of its physical characteristics, its rheology, its viscosity. The equipment base here in Swansea is second to none, and it allows us to not just come up with new ideas of new coatings, but also to really understand them and to really characterise why they might be so good, but also why they might not work as well. This then allows us to develop new and improved coatings and layers that might go down on top of them to make them even better, and ultimately to make them last as long as possible.